In this video, we will draw a DFA or an NFA for the language L2, which is the set of strings x over alphabet AB, such that x does not have an even number of A's. So first note, there's two ways we could go about doing this. Way one is to realize that not having an even number of A's means that it has an odd number of A's. Okay, odd is the opposite of even. The other way is to make the machine for the language that has an even number of A's and then take the complement. So let's try that method. Okay, so we want first a machine that's going to accept when we've read an even number of A's. Okay, so notice that 0 is an even number, right? So even numbers mean they can be written in the form like 2m, and 0 can be written in this form if m is 0, right? Okay. So let's start off our machine accepting on epsilon. Okay, so there's our even, our 0 even number of A's. And then if we see, so actually I'm going to move this up just a little bit so I have room to make the complement of the machine. Okay. So let's label the state even, and we're going to accept on even number of A's, and our first even number is 0. And let's call this state odd. Okay, so if I'm in the even state, even number of A's, and I read an A, I now have an odd number of A's. So I transition over there. But if I'm in the even state and I see a B, I still have an even number of A's. The number of A's hasn't changed by seeing that B. Okay, if I'm in the odd state and I see an A, I now have an even number of A's. But if I'm in the odd state and I see a B, I haven't changed the number of B's. So I still have I haven't changed the parity of the number of A's. So if I'm in the odd A's state and I read a B, I still have an odd number of A's, so I stay put. Okay, so this machine is going to accept whenever we have seen an even number of A's. Okay, but our L2 needs to accept when we do not have an even number of A's, so we're just going to take the complement of this machine. Remember, in taking the complement, what we want to do is any state that was a final state is going to be a not final state, and any state that was a not final state is going to be a final state. So we just swap final and non-final. So we had even is now non-final, and odd is now final. Stay the same. A, B, A. Okay, so this machine accepts when we have an odd number of A's. Same thing as accepting when we do not have an even number of A's.